really hope it's like 3s. That's where I'm at right now. Okay, so we're starting rational exponents, meaning that we have fractions as exponents. Okay, it's really not that terrible. I like it. Okay, so I know I'm weird. Okay, it's a thing. So I want you to realize when you have a fraction as your exponent, think about it. We need a root and we need an exponent. Well, y'all, where are roots? Think of real world. Where are roots? In the ground, on the bottom, right? Which one is on the bottom? So n is your root. And m on top is your exponent. So you can rewrite it one of two ways. You can rewrite the root with your exponent on the outside, or you can rewrite it with your root and the exponent on the inside. You can write it either way. They mean the exact same thing. They'll give you the exact same thing. But the big thing to remember is your root is on the bottom. Okay? Product rule, if your bases are different but they have the same root, you can combine them on the inside. Same with division. If you have two fractions, or not two fractions, two radicals, but the root is the same, you can combine it all under one and simplify first. Okay? Yes? Okay, so let's look at these. So these are asking us to change from exponential form to radical form. So I want to make it a radical just like we talked about. So what's my root? 2. And what's my exponent? 1. Now what I want you to realize is if it's a square root, do you have to put a 2? No. Square root can look like this. And if it's an exponent of 1, do you have to put it? No. So you can write either of these and I would accept both. But I want you to realize this is the way you'll see it properly. Yes? Now, what's our root here? 5. And what's my exponent? 2. Now, does 5 go into 2? So this does not simplify. That's your answer. Okay, what about here? So it'll be cube root of a to the what power? 5. Now, does 3 go into 5? How many times? Once. So that means I can take out 1a, and how many would you have left over? 2. Because 3 goes into 5 one whole time, and it has a remainder of 2. Yes? So it's kind of what we talked about yesterday. You don't have to show all those steps every time. Okay, now what about from radical form to exponential form? Well, if there's no exponent, what number can you put? A 1. So this is t to the 1/4 power. Remember, it's exponent over root. So what would this one be? b to the 7/3. And what would this one be? Yes. Okay, we're going to be going both directions in this piece of the unit. Okay, because it'll help you simplify a lot. Now, what's the best part about numbers 7 through 10? You can put them in your calculator. How do we know we can put them in our calculator? There's no letters. Y'all, there's no X. So you can literally type these in your home screen and get the answer. Okay, literally straight to it. 8 to the 2/3 gives me 4. Now I am going to show you why on just one of them, and the rest of them we're going to do in our calculator. So what I want you to realize is this is a root of 3, and it's squared. Well, there's two ways you could do this. You can square it first, or you can find the root first. It doesn't matter. You can square second. So what is 8 squared? So this is the same thing as saying the cube root of 64. Does 64 make a perfect cube? Yes. What would it equal? Does that make sense? And this little handy dandy sheet is what helped us find that. So there should be one on every group. If there's not, I don't know where it went. Look around. I'm sure it's on the floor. Now this is also in your packet behind the cover page. Okay, the rest of them, look at number 8. We can type in our calculator. To the negative 3 over 4, and I get 125 over 64. Now, do you know what to do if it gives you a decimal? You can hit math. See how it says frac? You can hit that and press enter, and it'll turn it into a fraction for you. Okay? So if it gives you a decimal, you can always make it turn it into a fraction. Okay, number 9, we're going to type it just the way we see it. And I get negative 343. Okay, and then this one. So I'm going to type it just the way I see it. What happens? It's non-real. What does that mean? Not quite. It has a solution, but what is it? It's non-real. What's another word for non-real? Imaginary. It's going to be an imaginary number. Because technically this is telling you to take the square root of negative 49 and cube it. Well, can you take the square root of a negative? What did we do with negatives before? We made it positive and we put an I in the front, correct? So then could I do, well, what is the square root of 49? So it gives me 343 still. So it'd be 343i. Does that make sense? If it ever says non-real, take the negative out and just put an I with your answer. And you can take the negative out and then do it in your calculator still. So, okay, so let's flip to the back. So those were the simpler ones. We are going to cross off number 15 because it goes too far. We haven't learned all of it yet. So, we're going to do these and then you'll have time to practice. Okay, excuse me. Okay, so we are going to have to do power to a power first. Y'all, I always get rid of the power to a power first because I need to get rid of the parentheses so I can do everything else, correct? So, technically, doesn't 256 have a power of 1? And then x has a power of 16. So we're going to distribute this power by multiplying. Well, what's 3/4 times 1? Yeah, 3/4. Okay, and what's 3/4 times 16? What's 16 times 3? Divided by 4. 12. Now you could have typed it as literally 16 times 3 over 4. Oop, might help if I actually type it. And it'll give you the same thing. Okay, so I don't have to do anything with this guy. He's simplified now. Well, can I type the rest of my calculator? And what do I get? So what's my final answer? 64x to the 12th power. Your final answer shouldn't have fractions as an exponent. So if they do, you need to turn them into radical form. Okay? Okay, so let's look at this one. Okay, I want you to realize this is the same thing as if we had a cube root of 81m4n12 over cube root of 3m. Now, we'd prefer it this way, but I just want you to see that these are the same because there are practice problems where it's separated. And on the notes, I put it together. So we would put them under the same house like this. So what do we want to do first? Should we simplify the inside first to make numbers simpler? Yeah, let's do that. So 81 divide 3. Remember, we treat numbers like normal. So I have cube root of 27. Now, I'm dividing, so what do I do to exponents of bases? when they match? We subtract. Well, I have an m on top and bottom. Where do I have more? So I'm going to leave the m on top. And what's 4 minus 1? And then where are there more n's? Are there even n's on the bottom? So it just stays the same. Everybody okay with that? Now there's two ways to do this. We can do it like we did yesterday, or we can turn them into fractions. Well, this has an exponent of 1, so this is 1/3. This is an exponent of 3 over root 3, exponent of 12 over root 3. And I'm going to show you why I did that. So 27 to the 1/3 power gives me 3. What's 3 divided by 3? And what's 12 divided by 3? Okay, does that make sense? It's a simpler way to simplify your exponents. Now, this is technically a 1. Do I have to put the 1? No. Okay, look at number 13. What is the rule for multiplying when you have exponents? What do you do to the exponents? You add them. When the bases match, they both have a base of a. You're going to add the exponents. Well, do they already have a common denominator? So what's 2/3 plus 5/3? 7/3. Remember, when you're adding or subtracting, the denominators don't change, but they do have to match. Okay? And how would I rewrite this? It'll be cube root of a to the 7th. Now, does this simplify? Does 3 go into 7? Twice. So I'm going to take out a twice. And how many do I have left? A remainder of 1. Because 3 goes into 7 twice with 6, and then you had 1 left over to make 7. Yes? Number 14 is pretty gross. It's the worst one, I think. But it's not that bad. Okay, so what's 1/8 times a negative 2? Y'all, you could do all this in your calculator. Almost. The multiplying. Negative 2 times 1/8 gives me negative 1/4. And negative 1/8 times 3, or sorry, positive 1/8 times 3 gives me 3/8. Okay, now I know this is hard to tell, but this is a negative 1/4. I promise on your notes, if there's a negative, it's way, or not, sorry, not notes, your practice, it's way more obvious. I'm going to move the negative to the top so you can actually see it. Okay, it's just so close to the fraction line, but see how small this fraction line is and see how big this one is? It's because the negative's touching it. So negative 1/4 times negative 3 gives me positive 3/4. And then negative 1/4 times 1 is negative 1/4. Now, when we have fractions, what do we do with our exponents when our bases match? Not add. Subtract. Now, where are there more a's, top or bottom? So a is going to stay on the bottom. And I'm going to do the exponent 3/4 minus the top exponent. Well, isn't that a negative 1/4? And what do I get? 1. Do I have to put the 1? No. Where are there more b's? Top. And I'm going to do 3/8 minus negative 1/4. And I get 5/8. Now the only thing we have left to do is write it as an exponent. What's your root? Not an exponent. A rational. What's your root? 8. So I'm going to have 8th root of b to the 5th power over a. 8 does not go into 5, so we're done. Okay, I like the last 3, but I'm weird, so there's that. Okay, you're going to turn these into fractions because you're going to simplify. Okay, so if you look at number 16, I'm going to change this to a to the exponent of 5 root of 10, b to the exponent of 15 over the root of 10. Everybody okay with that? And I'm going to simplify the fractions. If you don't like simplifying fractions, the calculator will do it for you. What do you get? So I know this becomes a to the 1/2. And then gives me 3 over 2. Are we okay with that? And now, don't they both have a denominator of 2? So I can put them under a square root, and I have a to the 1st power, b to the 3rd power. Which one of those simplifies? Which one has something that can come out? Yeah, the b. How many times does 2 go into b? I mean to 3? 1, so I could take a b out. And how many do I have remaining? 1. Well, a is still there because I couldn't take that out. But don't I have a single b left? Now, if you need to, you could show that work. We could have also done what I'm about to show you on this number 13. What I want you to realize is 3 over 2. What does that simplify to? If you had to write it, do y'all remember proper fractions? 1 and 1/2, right? Because 2 goes into 3 one time with a remainder of 1 over 2. Yes? Well, look, how many b's did I take out? 1. And didn't I have the square root of b left? So you could do that way as well. Okay, number 17. I'm going to write these as fractions because I need them under a single radical. Now, if they don't have an exponent, you can always put a 1. So this becomes x to the 1/6, x to the 1/3, x to the 2/5. To combine them, what do I need? Common denominator. What's my common denominator with 6, 3, and 5? Huh? $30. So we're going to do times 5 on this first one, and that gives me x 5 over 30 times, what would I multiply 3 by? 10, which gives me x to the 10 over 30. And what about 5?
6.
Which gives me x to the 12 over 30. Now, what do we do to exponents when you're multiplying? Add. So remember, when you're adding, denominators don't change. So we're going to have something with the denominator of 30, and I have 5 plus 10 plus 12, so I have 27 over 30. Now, before you change this into a radical, you have to simplify. Guys, your calculator will simplify it for you. What does it simplify to? Which number is my root? So I have 10th root of x to the 9th power. 10 does not go into 9, so I'm done. Yep. If your root is bigger than your exponent, you can't take anything out. Yeah. Now, if this was 9 and 10, you would be able to take 1x out and have 1 remaining. Yeah. Okay, last one. Okay, what's the difference here? That one was multiplying, so we made common denominators and we added. This one's dividing, so what are we going to do? Make common denominators and subtract. Okay, so when I write this as fractions, I end up with a to the 1/4 over a to the 1/5. Everybody okay with that? Can y'all see it? Okay. What would be your common denominator with 4 and 5? 20. How do you turn a 4 into a 20? Times 5. So that gives me a to the 5 over 20. And how would I turn a 5 into a 20? And that gives me a to the 4 over 20. Now what do I do? Subtract. What's 5 minus 4? So I get a to the 1 over 20. And that gives me the 20th root of a. Do I need to put the first power? If you do, is it wrong? No. Okay, they're really not bad. I did harder ones on your notes than in your practice. Oh, I do want to do one of your practice, actually. Hold on. Flip to number 3. Only because it's dealing with negatives, and we haven't done much with negatives since the first time we did exponents. So I just want to do a refresher over that. So look at number 3. Okay, so it's kind of like one of the ones we just did, except it has a negative exponent. So remember, 216 has an exponent of 1, x has an exponent of 3, and we're going to distribute in our exponent. So I get 216 to the negative 2/3 power, and I get x, well, 3 times negative 2/3 is negative 2. So all I've done is multiply my power to a power. Yes? Now, when you have negative exponents, it's because it's on the wrong side of the fraction. So I need to create a fraction and move them to the opposite side. Well, right now they're both on the top, so when I move them to the bottom, they become positive exponents. And the top cancels. Well, this is x squared, so cool, we're done with the x. But 216 to the 2/3, not that. 216 to the 2/3 power is 36. So I have 36x squared on the bottom. Sorry. Can you leave an empty top? No, so you have to put a 1. So that was my refresher on negative exponents. Huh? I typed it in the calculator. 216 to the 2/3 power. So all I did was type the number apart in the calculator.